Hello, Daryl here. The channel is Programming in Any Language. The supporting website is programminginanylanguage.com or black-duck.com. They both take you to the same place. And it's a place where you will find the videos and PDFs of the code. This video is Introduction to Classes. And welcome to Introduction to Classes. Up to now, you've been using classes. You've been using them every time you added objects to your forms. Microsoft provides you with tons of pre-made classes that help you with your programming. All those objects you pull from the toolbox and place on your forms are made from classes in the .NET framework. Arrays, lists, random are also made from classes supplied to you on the .NET framework. Well, this video is the first of several that will show you how to make your own classes and, in turn, instantiate your own objects. This first video will show you how and where to make your classes. Another video will delve into adding different properties to your classes. And, quite frankly, this can seem a little intimidating. I'm going to go slow and add different pieces of this in several videos. The concept of classes can take some time to master. When I first started programming, there was no such thing as classes. We did straight-line programming with the likes of COBOL and Fortran and BASIC. When object-oriented programming became the norm, the world changed. I had to unlearn what I had been doing and learn an entirely new way to create applications. And that also meant I had to look at problems in a different way. What should be a class? How do I know what classes to create? There's a lot to learn when it comes to object-oriented programming and classes. We'll take this one step at a time and learn it well. And that first step is this video. Let's see what this is all about. We're now going to jump into object-oriented programming to some degree, at least classes. Labels, text boxes, and so on all come from classes. So let's take a look at this now. This will be our introduction to classes we're going to be looking at today. And a class is really a blueprint for an object. It describes a particular type of object, yet it's not an object. It specifies the fields and methods a particular type of object can have. One or more objects can be treated from a class. Each object created for the class is called an instance of the class. That's the wording in this kind of thing. But let's take a look and try to see what all this means. So far, we've looked at buttons, labels, text boxes. Those are visual objects we've actually used. And we've used invisible objects as well. We've used the random number generator, arrays, list objects, image list controls. All those things had to be created from a class that was given to us in Visual Studio. They're already been prepared, so we're able to use this kind of stuff. And we created instances of those things to make it work. And before an object can be used, it must be created in memory. Before an object can be created in memory, however, you must have a class for that object, which Visual Studio gives us for these particular things that we're seeing on the screen right now. But we can also create our own. But let's take a look a little deeper. A class is kind of like this. It's kind of like a plan. We're looking at a plan of a house. We've got bedrooms here. We've got a great room, another bedroom, master bath, things of that nature are sitting out in this thing. And when we look at that, our class is really a blueprint of an object. It's code that specifies the fields and methods a particular type of object has. And it's not that different from architecture in many ways. We can take that blueprint and turn it into an object or an instance of the class. Much like we're seeing here. A carpenter will take that plan and build a house out of it. In fact, since we have the plan, we can create two instances of the class. Just like you create many instances of text boxes, labels, buttons, you can pull them all down. In fact, that class can be used to create many objects that are instances of the class. And the interesting thing is, once you've got those things created, like we have the three houses here, we could actually change the paint color on this house over here on the left. The one in the middle could be a different roof style, or at least a different roof color. But the thing is, you've got this plan. And from it, you create the actual object that you can use. One plan. If you're writing a program to catalog different types of reptiles, you might create a class called reptiles. This class would hold the fields, properties, and methods for holding and manipulating data common to all reptiles. This class will be a specification that objects may be created from. In your program, you could create the turtle object. It will be an instance of the reptile class and reside in memory with fields, properties, and methods specified by the reptile class. Next, you could create the crocodile object based on the reptile class. In fact, it would look something like this. You'd set up your reptile class, and from it, you could create an instance of turtle, an instance of crocodile, an instance of snake. But they all share properties that are common to reptiles. They may be different. Turtle's certainly different than a crocodile. But it still shares some things that the reptile has. Cold-blooded, scales, what else? Eyes, nose, they breathe. All stuff like that. The turtle, crocodile, and snake all share the fields, properties, and methods of the reptile class. When you create a class, you create it by writing a class declaration, which is a generic form looking like this. We have class, and then we have class name sitting up there. And then anything under here, all the member declarations go right in this place. The class header is on the first line. It starts with the keyword class, followed by the name of the class, as you can see. Member declarations are statements that define the class's fields, properties, and or methods. All those things can be pulled into this thing. A class may contain a constructor also, which is a special method automatically executed when the object is created. If we created a class named coin, to create a coin object, we use coin, myCoin equals new coin. MyCoin is a variable that references an object in the coin class. That's something we're going to name. The new keyword creates an instance of the coin class. This new is going to create that instance. And the equal operator assigns the reference that was returned from the new operator into the myCoin variable. Once the coin object is created, you can access members of the class with it shown as myCoin.toss. This happens to be a method that will be created inside that coin class. Here is the coin class, as a matter of fact. Notice here's the class coin, and here's all that stuff in the middle. We talked about the class name, and everything in between. The member declarations are sitting in here. So let's take a look at this. Class coin. All the stuff that's going inside it. What do we got in front? Well, we got a field. It represents the variable with the side facing up is what's going to be stored in here. So that's our class field that we're going to be accessing. We have a constructor here. So when we go into this thing, as soon as we create the myCoin from coin class, it's going to have a constructor which is going to set heads into the side up. It's actually going to store something in there. We then have a method right in here, a toss method, which is accessible outside the program from a button perhaps. And what it's going to do, it's got some code in here. It's got a random number generator, which is another class. It's pulling a ran and creating a new random. And we're actually setting it up that if ran next to 0 and 1 are going to be popping in here. If it's a 0, it's going to be a side up. It's going to store heads. Otherwise, it's going to store tails. So it's a random number generator that whenever toss is called, it's going to generate either a heads or a tails inside the side up, which it's stored in this string variable up here. We also have a get side up method, which we can access also from outside the program. And it's going to return side up. So whatever is stored in side up here is going to get returned through the get side up method. Here's the button. The button inside the program is called flip, button flip. And again, it creates the coin, myCoin equals new coin. This is going to create that coin class. This is going to call the toss method inside that class. And this is going to get the get side up. It's going to call the get side up method inside the coin class and send it out to a list box. If we tie it all together, we can see that when it's created, when the button gets pressed, button flip gets pressed, coin, myCoin equals new coin gets executed. This creates the myCoin instance of the class coin. And right away, because the constructor is set in there, it's going to create the side up equal to heads. And you can see the heads right here. We're going to take a look at that. Next, we'll go ahead and do the myCoin toss. We're going to actually execute the toss method of the class. So we say myCoin toss. It goes and executes this method right here. And the toss does the random number generator, figures out whether it's a 0 or 1, determines whether it's heads or tails based on that 0 or 1, then places the string heads or tails into the side up, which is sitting in the field that we have access to. So next, we do the get side up, which returns side up. It goes and gets what's in here and returns it to our list box. And we actually see it in place there. Let's take a look at this and see it in action. What I've got here is a form with a flip button, a clear button, and an exit button. The flip will do our work. The clear will clear this list box, and the exit will get us out of the program entirely. So basically, the flip button is where we're going to be seeing all our work. That's a little piece of code we saw a little while ago. The class is going to be inside our program someplace. So what we're going to do, we're going to go ahead and create this thing. So I'm going to double click on the exit button, and right away we end up with this button exit thing. And we can easily pop that into place. We've done this 1,000 times, so we'll simply place the close form button exit is done. So that's all coded in here. The next thing we want to do is we want to create a class. So I'm going to go into the code. So we're going to go right under here, and we're going to say class coin, and we'll give it the braces. So we've got a class set up here, and here's where we can put all our stuff for that particular class that we need. And the first thing we're going to do is we're going to create private string side up. And this will be a field to represent the side facing up. That's all we need to do. Now we're going to create a constructor. So basically the constructor is going to go right in here. This will be called public coin. This will be the constructor. And it's going to have a side up equal to heads. So we're going to actually establish the variable heads into the side up area when it starts. So as soon as we call that coin, my coin is actually executed. My coin is going to have a side up with a value of heads in it. You don't have to put heads in it. You can leave it null. But we're just going to put it in here for sake of argument. And you'll see how we can make changes to this later. So that gives us our side up. We're now going to create a method called toss. So inside this class, it's going to have the ability to toss a coin. So void toss is simply going to be an if statement checking the random value of rand, which is a random number that we're going to create here by using the random class to create rand and pop that in here. So anytime this is executed, we're going to actually generate a 0 or a 1. And based on that, we're going to put either heads or tails into side up, which again is up here. So it comes up with heads in it, but this, anytime the toss method is executed, it'll make a change to side up. The other thing we're going to do is we need to get this. We need to get the information from the side up if we want to display it any place. So we're going to create another method called get side up. We're going to pop that right here. So there's our return side up. Get side up is going to return side up. It's going to return what's in side up, what's in the field over here. So all this is working together. So if we look at the entire class itself right now, this is it. Starts with a coin, and inside here we've got a constructor, we've got a toss method, we've got a get side up method. And that's it. That's all we need for the class. Now how do we use this class? Well, this is where we get into the program. If we go into the program, we can go up into the flip button right here and basically place a couple of things into it. First thing we're going to place in here is the coin my coin equals new coin. We're going to create the object. The next thing we're going to do is ask it to toss a coin. MyCoin.toss. This is going to call the class right here. It's going to call this toss method that's down here and determine what side up is. Now in order to display it, remember we have this form here. We have a list box we're going to pop this thing into. So we're going to call get side up, which is going to take the value that's returned here and add it to our list box and make it work. That's all we've got to do. I do want to do the clear button real quickly so we can clear this thing out. And in there, we'll simply lay this in there. And now our program is done. We'll do a file save on it. Do a start. And do a flip. Tails. Flip. Tails. Flip. Tails. Flip. Tails. Flip. Heads. Flip. Heads. Flip. Heads. Flip. Tails. Flip. Tails. Flip. Tails. Flip. Tails. It's pretty consistent. Flip. Tails. And keep on going. Heads and so on the line. We then can clear. And that's our program so far. In C# you have the flexibility to choose where you want to write the class declarations. To create the coin class, you can save the class declaration as a separate CS file or add the coin class to the next to the form class inside the form1 CS file. And that's what we just did. We just did the second thing here. Well, we can also do it as a separate CS file, which makes it very nice because you can use the class then for other programs as well. So you can create one class that's going to work for a bunch of different programs. This is what you might see. In the case that we just did, we end up creating the coin toss demo one This happens to be test one. And you can see there's nothing here but the form CS file. If we were to create a separate CS file, coin CS file, it would appear like this. And we're going to do that in a second so you can actually see how that is actually done. Once again, we've got the same type of thing here. Flip, clear, exit, and so on. This time I'm going to make a slight difference to this thing. Instead of creating the class inside the form, I'm going to create it outside the class. So what am I going to do? I'm going to go into my CoinToss Demo 2 area right here, and I'm simply going to right-click on it and say Add. It's going to add new item. It's actually going to add a class way down here. Once I do that, I can then give it a name, and I'm going to call it Coin. And then add it. It creates all the necessary pieces I need for the coin, again, giving it a namespace, and then having our internal class Coin sitting right in here. I now can add all the things I had before in the other program. So what I'm going to do is I'm going to take all the data we had before and place it in here. And there's our class. Internal class Coin, and here's all our pieces that we need right here. And again, our constructor is sitting out here, our toss method is sitting here, and our get site up sitting here. That's in the class itself, as you can see. In the form, I can go right to my exit button. Let's pop that in right away and do that first thing. You can't see any class here, but it's there. So I'll make my exit button work. And I'm also going to go ahead and get my clear button in there so I can clear my list box up. Lay that in here. And then I'm going to create my button flip. My button flip is going to have the same 3 lines of code I had in the last program. No changes made to it whatsoever. And it's going to look like this. Coin, my coin equals new coin. We're creating the coin object. The my coin toss routine, and then the get site up is sitting here. And that's all I need. I'll do a file save on all this. And I'll do a run. And I'll do my flip. Heads, heads, tails, heads, tails, heads. Okay, a bunch of them. It's working just fine. I can clear it, start over again if I want, and it works just fine, as you can see. So it doesn't make any difference where the coin class is, if it's sitting inside the form or if it's sitting external to it in its own little piece here. The nice thing about this is, though, I can grab this and I can use it for another program if I'd like. Now that you've seen that, a field may be accessed by any method of the class which the field is declared. A field is declared as private. It cannot be accessed by code outside the class. If a field is declared as public, it can be accessed by code outside the class itself. You'll see more of this as we start to work with this and see how classes actually protect our data. It's basically encasing our data into this bubble, and we could only get in and get out through certain methods, which we're going to be exploring in the next video as we get into this thing. But for now, you can understand the scope of the fields here, that it's very, very private to these things. We can't really get access to these things unless we use methods that were created within inside the class. We can initialize a field in its declaration statement the same way we initialize a local variable. It can be initialized after the name field. You write an equal operator followed by a value. Private string site up equals heads. We didn't do this. We did it inside a constructor, but we could have done it like this and put heads in there initially. Again, we're changing it with that random number generator, so it didn't make any difference if we did or not. But you can initialize the field at declaration. Now, number one, you don't have to have one field. You can have several fields inside a class. You're not restricted to one. In this case, we're just using one, but you're going to see some examples down the road here in a few future videos. We're using multiple fields to work with our objects. If you don't initialize the field, if it's uninitialized and is not assigned a value by the constructor, it is automatically set to a default value determined by the field's data type. And that's simple. It's basically the low end of the totem pole. If it's an integer field, it's set to 0. Floating point 0.0. Boolean fields are false. Char fields are set to a /backslash 0. String fields are set to null. Reference type fields are null. 0 enum fields. And it's a struct. You can have structs in there as well. It's, remember, they're set to default values determined by their type as described above. So if we have a bunch of strings in our struct, we have all nulls sitting in there. If we can have strings and integers and doubles inside there, you would have null, 0, and 0.0 for those particular things as well. That's all you have to do there. You can pass an object to a method. So an object of a class can be passed as parameters of a method. For example, here's the private show coin status, coin. MyBox.show side is coin, get side up. Here's that get side up method we saw inside our class before. If you include it within this thing and have the coin piece in front of it, my coin in front of it, you can actually pass it to the message box. So the message box show will actually generate the get side up, and you'd see either heads or tails showing up in your message box. In this example, that method show coin status accepts the coin object as an argument to create the coin object and pass it as an argument to the coin status. You use the coin, my coin, new coin, show coin, my coin. So we're actually doing that like this: show coin status, my coin. So this is a show coin status, and we're going to send it my coin into something called coin, and it goes ahead and gets it. So that's pretty much, in a nutshell, how to establish a class. We're going to see a lot more interesting thing as we go forward on this. In fact, in the next video, we'll be looking at properties that you can associate with this thing. Because one thing you have to remember, let's just take a look at this real quickly here. When we look at our form and we look at all these objects we have on there, like flip, they all have properties associated with them. We have properties inside that coin class as well that we can actually establish. We certainly have the side up property of heads, it's holding up something in here. We can create many other properties as well as we go into this thing. So you're going to see that take place as we go forward. So basically, when you start looking at this kind of thing, let's extend this out real quickly and grab our toolbox. If we happen to grab a label and pop it on here, our label's sitting there. Our button is sitting right here. And we can create multiple buttons. There's a bunch of buttons here. And we can take these buttons and once we have the instance there, we can change some of the properties on them, like the width property, the height property, the font property, colors, all those kinds of things can be changed as you get into it. So you're starting with an instance that has the ability to make changes or shapes based on how you adjust those properties. So you can give an object properties. We're going to see that in the next video. But right now, this is how to actually set up a coin class in a nutshell. Okay, we created a class that can flip a button. I could do that before without using any classes. What's the point? True, you don't need a class to do what you saw in this video. But as applications get more and more complex, you'll find that creating classes will help you tighten your code by making separate shareable modules for many of the functions you need in your program. In our next video, we're going to look at properties we might add to classes. And we'll follow that with examples of how we can add several properties to a single class at the same time and still protect that data from getting changed accidentally. Meanwhile, thanks for watching. Visit the website when you get a chance. Oh, and please subscribe to the channel. There's more stuff coming every week. We'll see you next video. Take care.